Hello everyone, today our topic is greening on existing buildings, techniques and feasibilities. The first part to be discussed is the reduction of energy use. The reduction is possible because most of the existing equipment were built before the latest energy efficient technologies were developed, so there is a great room for them to be improved. There are numerous electric motor driving systems in existing buildings. For example, it exists in the cooling system, and a substantial energy losses occurred when the power output cannot match with the requirements of energy. It's because without VFD, we cannot control the rotating speed of motor. But with VFD, we can control the frequency of power supply, which means that the speed of the motor can be controlled, and we can lower the energy requirement for EMDS, and we can hence reduce the energy loss in the system. We may replace the traditional light bulb with the LED in existing buildings because they consume 42% less energy than the existing light bulb type. Also, they has a longer lifespan, which means that less waste or pollution will be produced during the disposal. It is beneficial to the greening of existing buildings.
Deep water cooling system can reduce the use of electricity in the air conditioning system. The fundamental concept of it is using cool seawater to provide their cooling energy to the heat exchanger, therefore providing chilled water to cool the buildings. It replaces the needs of having chillers at the customer's site, and most importantly, it cuts off the large amount of electricity that is needed to support the chillers for air conditioning. In terms of procedures, it is based on the diagram on the top right. Firstly, the seawater is extracted at the bottom of the sea, which means the extracted water is very dense. And one interesting property about water is that it is the most dense at 4 degrees. Therefore, the water that's being extracted is always steady at around 4 degrees, hence minimizing the effort needed to maintain the water temperature. Secondly, the cool water then flows to heat exchangers at a station and is used to cool the water in the closed chill water supply. Thirdly, the chilled water then flows out and meets another heat exchangers at customers' building, providing chilled water for their internal cooling system. Fourthly, after receiving heat from the heat exchangers, the original chilled water turned into warm water. It then goes back to the first heat exchange station to transfer the consumed heat back to the cool seawater, and the cycle repeats. The cool seawater becomes warm water as well after receiving heat from the first heat exchangers, and unlike the traditional chiller plants that transfer the warmed water back to the sea, this warm water is supplied to the public as drinking water after additional filtration, therefore making this whole system environmental friendly. Ultimately, it uses relatively little electricity compared to chillers and can save up to 90% of the electricity used for air conditioning.
Next, I will talk about the utilization of water resources. The fundamental principle of rain harvesting system is to recycle rainwater. It collects rainwater from pavement, garden lawns, and building roof for further usage like toilet flushing. The rainwater is filtered and stored to remove debris like sand, dry leaves, and free branches. It is not usually for the purpose of drinking, but for other purposes like toilet flushing. So these are the components of rain harvesting system. We need a water storage and holding tank for water storage, and control unit is to monitor the temperature and the pressure of rainwater. Filter is for purifying, and pump is for transport of water. As this rainwater is not used for drinking, we need a separate pipe system, And also, if the rainwater harvesting system is not working, we need a backup water supply and piping. So when we consider the feasibility of installing rainwater harvesting system, we have to think, is it possible to install the components like space is enough or is it efficient enough? There are some green benefits to the building. The first one is it has a high level of water saving efficiency. Like when rainwater is used for toilet flushing, it can save the cost. Also, the pumping cost will be reduced if we adopt the gravity-based design, as the harvest rainwater is transferred by the means of gravity, the pumping cost is reduced. And most importantly, it can reduce the freshwater usage. Like for gardening, we can use the harvest rainwater instead of fresh water for further usage.
Now we're going to talk about the utilization of renewable energy, which is the natural resources and environment energy that is provided by using the sunlight, wind power, rather than using the fuels such as oil and coal to provide energy for daily use. We mainly focus on talking about biomass and solar energy from three dimensions, from the introduction technologies and disadvantages and advantages. For the biomass, it is describing fuels which are made from the animals and plant waste. It's an energy form in which energy is stored in the living organism by the photosynthesis in the form of chemical energy. Solar energy is a radiant energy emitted by the sun. It's a conversion of sunlight into electricity by active and passive way for the use in home, school, hospital, and other infrastructure. These are some technologies applied in the existing building to produce biomass and solar energy.
Festival Walk is a great example of how existing building can be improved through the use of different technologies. Actually, it has received patent rating under the BRE plus existing building schemes. It's the top rating under the scheme, which means that it has a great improvement in the energy performance. The Swire Properties management teams has utilized different energy equipment to reduce the energy consumption in the buildings. For example, it uses VFD in air handling units and ventilation fans. Consequently, 450 million watt per hour energy use is reduced. Also, it installed LED with smart lighting system. The photo and motion sensor control in the system control the amount of light energy given out so that unnecessary energy loss can be reduced. The management team has also installed green roof, an automated sunshade shelter, and reflective glass curtain wall in the buildings. They can absorb and reflect the heat energy from the sun so that the cooling load of the building is reduced. Festival Walk has utilized water resources wisely. They installed water-efficient taps and recycled water from the cooling tower and sprinkler system, and these approaches help reduce the use of water. To conclude, it's possible for us to use different technologies to improve the greenings of existing buildings. And Festival Walk is a good example of how can we implement these technologies in Hong Kong. So it's the end of our presentation. Do you have any questions?